agnostic. I'm not sure what to speak on. But we know that, okay, what is the future? The future is going to be that of images and videos. Why? Look at this. There are 20 million videos on the internet. A billion new videos get added each month. So that we don't see any signals of the image, the databases on the image and video databases on the web saturated. Which means that we have huge challenge ahead that we need to work with such databases. It is not only internet. The online video is exploding. In addition to that, if you look at the TV channels, there are 200 plus satellite TV channels, mostly far more than that. Video collection. You are going to see all of them. You select and you, at the best, you can see 24 hours of TV. What about the rest? Are they useful? Quantity of images every day. You create huge multimedia data every day. Where do you store it? You may store on a digital computer. You may copy. You may put in your heart. So we have huge multimedia data around us and we have no mechanism to access them is the problem what we are facing. So media data is increasing. Online video is booming, broadcast video is huge, technologies and devices fuel this trend. But what we are all busy. We don't have time to see all of it. We want essence of it, summary. We want to get the relevant information from that huge data. I have questions like, tell me who won yesterday's cricket match and who hit that very interesting six I heard about from my friend. I just want to see that clip. So I have a lot of queries in my mind to give to my multimedia data. Which may be text queries, which may be imagination, which may be example queries. But I am not able to access them, I am not able to process them. Even if I am able to store them. Storing itself is a risk. So user demand is rising. And on top of it, Google creates huge expectations. Like you have text search engines where you give a text query and you get reasonable answers. Your expectations are set. So we are at a very, very critical stage where expectations are set, data set is available, algorithms not available, systems not available. So this is what actually motivates, the gap is huge and it is increasing. And now why we need this, there's no question about why do we need image and video retrieval. It's obvious that without that, there is no way ahead for us. So I'll start by this. A few of the systems and applications what we have worked on in the recent past and connect to the future trends or possibilities that are evolving. So this talk I will try to minimize the technical details of the algorithms and try to give you an idea about how such systems can be built and what does it actually take, how do we actually build some systems block by block and solve problems. So I start by talking about the traditional CPAR. So this has been there for a long time. Like I'm sure at least half of you are very familiar with the word CPAR, content-based image retrieval. So we would like to start from here. What is CPAR? It has been a mechanism where large image or video database, it extracts some features and build a feature data. So extract features means convert these images into some numbers. Convert some images into some, this could be color, this could be shape, this could be movement, this could be shape, this could be anything. Now you convert this image into a feature database. So popular techniques starting from color histograms to Fourier, wavelength descriptors, everything people have used. Now once you have this feature database, the next step, if you want to actually build a system, this is not the end of the thing, it's only a name, CDA. What we need a new index structure. We need the system to work with millions of images. So you need an index structure which works on these features which your traditional databases won't do. You need a different database which it can index these features and retrieve the images based on a nearest neighbor search or a classifier. So you have algorithms, the classical algorithms of nearest neighbor computation or approximate nearest neighbor computation, or sometimes a classifier, it's a single class classifier or even a multi-class classifier. They typically, given a query image, it computes the nearest neighbors and efficiently returns the retrieve. So this has been the traditional CBA, I don't know, maybe 10 years back or 15 years back, this has been the same. We have actually at present far ahead of this. So, given a query now, query is an image. Unfortunately, we have a lot of situations where you can give a query as an image, as an example, and retrieve it like text, you give a text query and get text back. Similarly, image, you give us an image as a query and get images back. So I give a natural scene as an image, query, and get similar images as a And how do we decide the similarity? Similarity is based on the features what we use and the type of classifier or such one. This was also not very satisfactory. So people went beyond that. They introduced a user into the middle. So there is a user. User says that, okay, no, I'm not interested in this. This is okay for me, this is okay for me, but this is not okay. User is able to do some dialogue with the search engine. So this has been found the relevant feedbacks where user is in the picture and user is improving the classifier or the nearest neighbor search dynamically. So even in this case, so the problem is now there's a classifier which needs to be trained with user feedback online. So user is expecting that, okay, I have a million database images and I give a query, I need the image, the result in few seconds. So the main issue in front of CBA has been the scalability and utility of it, of course.